Welcome to The Explainer. So today we're jumping headfirst into probably the biggest invisible mystery in the entire universe. Think of it like a cosmic detective story. We're gonna hunt down what's really holding everything together. So let's follow the clues and see where they take us.
Okay, so you think we have a pretty good handle on things, right? I mean, everything we can see, stars, planets, even you and me, it all seems to follow the nice, predictable rules of gravity. But here's the thing. When astronomers started zooming out, looking at the really big picture, they found a problem. And I'm not talking a small problem, I mean a huge one. A problem so big it suggests our entire understanding of the cosmos might be, well, just plain wrong. Get this, it turns out that everything we can actually see, all the stars, all the galaxies, all of it, that's only about 5% of the universe. Just 5%. The other 95%? It's a complete mystery. We know it's split into two different mysterious things, but today we're zeroing in on just one of them. We're hunting for the stuff that's responsible for all the universe's missing gravity. All right, so to kick off this investigation, we've got to look at the evidence. Let's head to the scene of the crime, so to speak, where the clues are just screaming that our cosmic math is way, way off. So here's the absolute heart of the problem. You take a galaxy, right, and you add up all the stuff you can see. Every star, all the gas, all the dust. You get a number for its mass. Simple enough. But then, when you actually measure that same galaxy's gravity, it's about 5 times stronger than it has any right to be. There's this enormous amount of extra gravity coming from somewhere, and we have no idea where. And this isn't just some one-off fluke. Oh no, the fingerprints of this anomaly are all over the cosmos. For starters, we see entire galaxies spinning so ridiculously fast that they should just tear themselves apart and fly off into the void. But they don't. Something invisible is holding them together. We also see light from super distant objects getting bent and warped as it passes by. Something with a lot of gravity that we can't see. And just recently, the James Webb Telescope spotted a galaxy. This one's called JWST ER1G, that has 6 times more gravity than its visible matter could possibly create. The evidence is piling up.
So with all this evidence staring us in the face, it all points to one prime suspect, a mysterious, invisible something that could solve this entire cosmic puzzle in one go.
And so scientists came up with a name for it. Dark matter. Now, it's called dark for a really simple reason. It doesn't give off light, it doesn't block light, it doesn't reflect light. It's basically a ghost. But, and this is the absolute key, it has gravity. A ton of it. In fact, we think there's so much of it that it outweighs all the normal stuff we can see by about 5 to 1. And what's amazing is that this one suspect, dark matter, it just neatly solves 3 of the biggest puzzles in cosmology. First, it explains why stars way out on the edges of galaxies are moving just as fast as the ones in the middle. Second, it perfectly explains the tiny little temperature ripples we see in the afterglow of the Big Bang, the cosmic microwave background. And third, it shows us how these massive sprawling structures like galaxy superclusters could have formed so fast after the universe began. It's like the perfect cosmic glue holding everything together. Okay, so we have our prime suspect. Now the hunt is on. All around the world, scientists are running these unbelievably clever experiments, all designed to do one thing: finally catch a single particle of this invisible stuff. And they're looking everywhere. I mean, they're going deep underground into these super shielded labs, hoping to catch a stray dark matter particle, what they call a WIMP, as it bumps into a regular atom. At the same time, you've got the Large Hadron Collider smashing protons together at nearly the speed of light, trying to create a dark matter particle out of pure energy. And then there are these other wild experiments with things called haloscopes, which are basically these incredibly sensitive radios trying to tune into a signal from another potential candidate, called an axion. But here's the big twist in our cosmic detective story. After decades of searching, after spending billions of dollars on all these amazing experiments, we found nothing. Absolutely nothing. Zero. Zilch. The prime suspect has a perfect alibi. It's completely eluded capture. And that, you can imagine, is making a lot of scientists very, very nervous. So, while this search continues, some really, mind-bending ideas about dark matter's role in the universe have started to pop up. It seems this invisible stuff might be a real double-edged sword. Our creator and maybe our destroyer. Let's start with the good news. We might literally owe our existence to dark matter. Think about it. Its incredible gravity probably acted like a giant cosmic net. It caught all those heavy elements, carbon, oxygen, the stuff we're made of, that were blasted out by ancient exploding stars. Without dark matter there to hold that stuff together, the building blocks of planets and of life itself might have just, poof, drifted away into the empty void between galaxies. But yeah, there's a flip side, a much darker theory. Some scientists think that as our solar system makes its long journey around the galaxy, it sometimes passes through these really dense clumps of dark matter. And the gravity from these clumps could be just enough to nudge comets out of their stable orbits and send them hurtling right towards us, triggering mass extinctions. Yeah, like the one that wiped out the dinosaurs. And this isn't just a wild guess. If you look at the geological record, there's this really startling pattern. These huge catastrophic impacts seem to happen on a pretty regular cycle, about every 30 million years. And guess what? That timing lines up perfectly with our solar system's journey as it bobs up and down through the most dense part of our galaxy, exactly where we think dark matter should be most concentrated. It's a little spooky, right? So the fact that we found nothing, it's pushed some scientists to a really radical idea. What if we've been chasing the wrong suspect this entire time? What if the problem isn't some missing matter at all, but a massive flaw in our understanding of gravity itself? This brings us to a whole different class of theories. The thinking goes like this. Instead of making up a whole new kind of invisible stuff to account for all that extra gravity, maybe, just maybe, our laws of gravity are wrong. I mean, the laws from Newton, from Einstein, maybe they're just incomplete. What if gravity just works differently on massive cosmic scales than it does here in our own backyard? One of the big alternative ideas is called MOND. Basically, it suggests that gravity just gets stronger when its pull is super weak, like way out on the edges of galaxies. And then there are even wilder ideas, like the idea that space-time itself has glitches or defects, things like cosmic strings or shells, that can actually create gravity out of nothing, no mass needed. And they would look exactly like the effects we blame on dark matter. So where does that leave us? The case is still very much wide open. And we're staring down one of the biggest questions in all of science. Is there an entire invisible shadow universe all around us, made of particles we can't see, that's secretly running the show? Or are we about to tear up the physics textbooks and rewrite our most basic laws of gravity? We don't know yet, but you can be sure the hunt is far from over.